Now let us discuss about greatest and least value of the function. Greatest and least value of a given function. Greatest value is also called as absolute maximum or global maximum. Greatest value is also called as global maximum. Least value means absolute minimum or global minimum. To find these values, first we have to find points of discontinuity. Point of discontinuity. Second, points of non-differentiability. Points of non-differentiability. And we have to find functional value at the end point of the domain. Functional value at the endpoints of the domain. And moreover, local maximum, local minimum, local maximum and local minimum values we need to identify. To find greatest and least values, we have to find points of discontinuity, points of non-differentiability, endpoints of domain, local maxima, local minima, and their functional values. After that, we can identify greatest and least value if exist. For example, if we consider a function f of x as x cube minus 3x in the domain closed -2 to 5 open, find greatest and least value. Find greatest and least value of the function in this domain. For that, we have to analyze all these points. Analyze values and hence find greatest and least values if exist. Let us do all that process for this problem. Consider the problem f of x equals to x cube minus 3x in the interval closed -2 to open 5. We need to identify greatest and least values if exist. First, let us focus on points of local minima and local maxima. For that, f dash of x, let us take f dash of x. It will be 3x square minus 3 means 3 times x square minus 1. Make this equal to 0. Then we will get x value either 1 or minus 1. It is very clear. X value is either 1 or minus 1. Okay. So, consider f of x once again. We can write f of x as x into x minus root 3 into x plus root 3. Is it very clear for you? Next, consider here -1, here 1. So, f dash of 1 plus f dash of 1 minus f dash of minus 1 plus. This is f dash of minus 1 minus. Okay. So let us discuss the sign changes. Right side of 1. What about f dash? Right side of 1. X minus 1 into x plus 1. This is right side of 1 means more than 1. More than 1. It is clearly positive. Okay. Here you have to check. Left side of 1 means it is negative clearly. Means first it decreases, after that increases. Means 1 is point of local minima. Then what about negative 1? Negative 1, negative 1 plus, let us take. Negative 1 plus means minus 0.999. Okay, minus 0.999. What it will be? Negative clearly. Okay, negative. Clearly here you can observe negative sign. The same thing will happen here. Okay, so left side of negative 1. Left side of negative 1 means what it will be? What it will be? Positive you'll get. Okay, yes, is it clear for you? Negative into negative becomes positive. Negative Negative into negative becomes positive. So that's why here I can take positive. First it should increase, after that decrease. So negative 1 will be point of local maxima. Okay. So x is equal to negative 1, point of local maxima. X is equal to 1, point of local minima. That's it. First find f of minus 1, f of 1. F of minus 1 will be here. F of minus 1. What it will be? F of minus 1. Or here also you can substitute. F of minus 1 will be 2. F of 1 will be, F of 1 will be negative 2. 1 you have to substitute here. So F of minus 1, F of 1 I got. Okay, next. Functional value at the endpoint. F of minus 2. Endpoints of the domain. F of minus 2. It will be what? F of minus 2. It will be negative 2. Here you have to substitute in place of x minus 2. F of 5. F of 5. Actually, 5 is not present here. 5 is not present here. F of 5 means left side of 5. Left side of 5 actually. So means limit extends to 5 minus x cube minus 3x. Actually, we need to identify. So its value will be 5 cube minus 3 into 5. Its value will be 110. Okay, 110. That's it. We got all the respective values. Okay, let us try to draw the graph. First of all, take x-axis and after that y-axis. Now mark minus 2 and 5. Minus 2 and 5 I have marked. Now listen carefully. Clearly function roots are negative root 3, root 3, 0. Negative root 3 means location I can observe here. Negative root 3. Okay. So, and moreover, I can take here negative 1, here 0, here positive 1. I can take here positive 1, here root 3, root 3. Okay. That's it. So, let us try to draw the graph. Listen carefully. F of minus 1 will be 2. F of minus 1 will be 2. F of 1 will be negative 2. Mark that first. So f of negative root 3 will be 0. F of 0 will be 0. Here you can observe. F of root 3 also becomes 0. Okay. So listen carefully. Uh, f of negative 2. F of negative 2 will be negative 2. Negative 2. F of 5 will be 110. 110 means approximately I can take here. Okay. So, but it will not come. Take a open circle. Now let us try to join all these observation points. Function look like this. Okay, approximately function look like this. That's it. Okay, listen. What about this negative 1? Negative 1 will be 2. F of negative 2 and f of 1 both gives the same answer. Negative 2. Now, find out the range of the function in this interval. Range. Wait, range will be close negative 2 to 110 but open. 110. Okay. 110 but open. Okay. So listen carefully. Maximum and minimum values which are global, you can observe in the range. Least value of the function in the given domain, it will be negative 2. What about greatest value? Yes, very good. Greatest value will be does not exist. That will be the analysis for the global maximum and minimum values for the given function in the given interval. That's it. Next problem, y is equals to x into e power x. Analyze greatest and least values if exist. F dash of x. UV formula we need to apply. If you apply that, it will be x into e power x plus e power x. It will be e power x into x plus 1. F dash of x we have to take 0. Then x will be negative 1. Okay. So what will be our observation at negative 1? Listen carefully. At negative 1, if you see right side of negative 1, the sign of f dash of x. Right side of negative 1, the sign of f dash of x will be positive. Left side of negative 1 means negative 1.001 like that. So it will be clearly negative. Okay. So first it should decrease. After that it should increase. So local minima. X is equal to negative 1 is point of local minima. F of negative 1 immediately let us identify. F of negative 1 will be what? E power negative 1 into negative 1. So negative 1 divided by E. That's it. F of negative 1 we have found. So what about domain? Domain of the function will be negative infinity to infinity. So we need to identify functional value at these inputs. So because these are undefined, what we have to do? Limit extends to infinity f of x if you identify approximately at infinity what the function behaves that we can identify. So at extends to infinity, functional value is does not exist. So let us identify limit. limit extends to infinity x into e power x. This is nothing but infinity into infinity. Infinity into infinity means reaches infinity. So does not exist. But what we can understand, whenever x is reaching infinity, function f of x reaches infinity. That we can understand. What about at negative infinity? Limit extends to negative infinity, f of x we need to identify. Limit extends to negative infinity, f of x is what? X into e power x. So listen carefully. X into e power negative infinity we have to identify. So here x into e power x, wait, x into e power x means negative infinity we have to substitute. We can write this as x divided by e power negative x. You can identify that, whenever x reaches negative infinity, this reaches negative infinity. Okay? 1 divided by e power negative x. What about this? 1 divided by e power negative x. So whenever x is reaching negative infinity, it becomes what? E power infinity means infinity. Okay, numerator infinity, denominator infinity. So infinity by infinity form we can apply. So this is limit extends to negative infinity, x divided by e power x, infinity by infinity form. So LH rule, limit extends to negative infinity, 1 divided by e power negative x negative. Okay, now let us substitute in place of x negative infinity. Then it will be negative 1 divided by e power infinity. 1 divided by e power infinity means 1 by infinity means reaches 0. Okay. So whenever x is reaching negative infinity, function reaches 0. These are the most important points. This one and this one. These are the most important points. Let us try to draw the graph. Okay. We have to locate negative 1, and if you observe the function at x is equal to 0, it becomes 0. At x is equal to 0, it becomes 0. At negative 1, it becomes negative 1 by e. Let us take this is negative 1 by e. At negative 1, it reaches negative 1 by e. Okay. Now, whenever x is reaching negative infinity, function reaches 0. It will not touch, it reaches 0. 0 means x-axis. So, the graph should be like this. After that, increase. Okay, whenever x is reaching infinity, the function reaches infinity. Okay, graph will be like this. Okay, that's it. It will not touch x-axis, seems to touch. Why? Because whenever x is reaching negative infinity, function reaches 0 means seems to touch x-axis. Whenever x is reaching infinity, function reaches infinity means function increases. Okay, that's it. What about range? Range of the function will be closed negative 1 by e to open infinity. So from here to infinity. That's it. Function least value negative 1 by a, function greatest value does not exist. That's it. That is the analysis. అర్థమైందమ్మా? Do these problems as homework and analyze greatest and least values for the functions in their domains if exist. That's it.